Oh man, this was a challenging day. Gee whiz. Uh, yeah. So I'm looking for anybody who has some in-depth air-cooled experience of any kind. Just literally anything. How you doing, Frylock? I don't know if you like your actual name being used on here, but how you doing? Yeah, I need help. I'm in trouble. When I say I'm in trouble, I'm in an awkward spot. So I've got a data center. It has a YCIV air-cooled screw machine on top of it. It's variable speed. It's a variable speed compressor, so there's no slide mechanisms or anything. And what I've got going is the compressor was having issues. It tripped. Well, let me back up. The whole saga of what started. We finished some repairs last week on like Wednesday or Thursday on a different chiller. When that system ran over the, let me see, I'm trying to get my story straight here. They ran, so we finished repairs on chiller 2, wasn't it? No, it was chiller 1. So chiller 1 we finished repairs on like Wednesday or Thursday. They ran chiller 2, I'm sorry, they ran chiller 1 all day Friday with no issues, and they have building automation on this system, so there was no issues. Everything did fine. So end of day Friday, they let chiller 1 turn back off, and they wanted to run chiller 2 in lead, so they did that. Chiller 2 was running lead. Saturday night, now this is a data center. So Saturday night, something happened to chiller 2 circuit 1. So on circuit 1 of chiller 2, the oil line or something tied into the oil. We're thinking it was the oil line. We have yet to identify that. That's not the priority here. Anyway, it broke. When that circuit shut down because it vented all the oil and charge completely, that ended up causing circuit 2 and 3 on chiller 2 to trip out on a current. So I think that kind of makes sense. It all just kind of tied together, and everything kind of tripped and freaked out all at the same time. So that's not that big a deal. I'm not worried about that. All right, so fast forwarding. Chiller 2 basically is completely down at this point. So chiller 1, we need to have online now to catch the load. So we have three chillers total on this building. We have our 2 primaries, which are 397 tons each, and then we have a pony chiller, which is kind of an emergency backup, if you will. I forget the tonnage on it. It's probably somewhere around 200 tons, maybe 250. It's not that big. So the entire time we've had the pony chiller online to try to help make sure that chiller 2 and chiller 1 will run stable. So when 1 tried to turn on, keep in mind this was all Saturday night. When 1 tried to turn on, it didn't run very long at all, and it started having trouble and started cycling down alarms. It just ran perfectly fine Friday. Now, disclaimer, circuit 2 on chiller 1 is down. Has been down for about a month. We're working on situating that. So we have circuit 1 and circuit 3 on chiller 1 that should be functioning. Where that left us is chiller. That left us, so Sunday, we roll into Sunday at this point, and they can't maintain the building. They do have the capacity to reset the systems remotely, and they were constantly trying to do that, but to absolutely no avail. They were not able to get the chillers to pull the building down. So we're running, 50, 60 something degree water on this data center, and everything's freaking out, right? We were able to basically shut all of the building down except for the critical pieces in the data center, and there was just enough capacity in the Pony chiller to maintain just those spaces. So that got us through Sunday night into Monday morning, and the plan was meet on site Monday morning and look at it. All right, so we get there, we get to looking at it all, and I'm sorry, I got so many things in my head trying to figure this out, so you just bear with me. When we got there, they had already been there a couple hours, and they were constantly resetting the chillers, trying to just get something to catch and go. So when I went up to the chillers, there was a circuit on chiller 1 and 2 that were constantly tripping. What that led to was, so with the YCIV, if you don't know, the circuits are always together. So the circuit that would run, every time the circuit that kept tripping would trip, it would bring that circuit down. They couldn't get control. So inevitably, what I decided, looking at everything, chiller 1, circuit 1 was our best bet to get online. Okay, so this is where I need help, and if anybody has any screw experience on these YCIVs, or just any of these York compressors, just please. Anyway, that being said, I'm going to create a Zoom meeting. If somebody has any input, if anybody has any input, let me know. And what I'm going to do, or you can go into this and we can actually talk about it over the phone. Hang on, I need to figure out how to share this. Come on, this can't be that complicated. Oh, you know what helps? You hit the big share button. That tends to do it. Right? No, come on. I want to share. This is not working. Come on. So, while I'm trying to figure out how to post the link, here we go, invite link. I got it now. Ha 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 ha. Be smarter. Come on. All right. The compressor at startup, so it's running at 50 hertz, so it's a 200 hertz. At 50 hertz, it is running 85 to 90% RLA, which on these particular compressors is 150 to 160 amps ish. That's at startup, and the compressor is growling. So it's having a growl, which initially indicates, so that the two typical things with the growl like that, I know is oil, and I know it could be an IGBT. The IGBT has been replaced within the last year, and I'm fairly confident that it's okay. So I don't think we're having a frequency issue from the inverter itself. So if it's not a frequency thing, then I'm wondering, do we have I went into the oil. So my next step is I checked the oil separator, and I found the oil separator has we had at the time we had a little bit in the lower sight glass. I could see standing oil in there, but it did not. It was foamy. Now this system had been cycling constantly for a couple of hours. What the building people were doing, and it's not any fault of theirs. They were just trying to catch the building load. So they were going in, and every time it would trip, they'd reset it. It'd go through the delay, start up, run for about 60 seconds, and trip. So we had a little bit of oil in the reservoir, but it was very foamy. So when I saw that, and I'm looking at the compressor, the entire compressor is completely saturated in condensation and cold to the touch. So my next thought was, okay, I've got to be flooding, right? Just flat out, that whole compressor is cold. I wanted to see, I've verified via touch, crankcase heater was definitely working. It was hot. So we had the crankcase, and and we had standing oil at the time. The compressor at startup, so it's running at 50 proof. So what I did from there, yeah, so we had the goodness gracious, sorry, the oil was there in the separator, but I was still having the growl, and I did not like the foam. We were sweating like crazy. Crankcase heater worked. From there, that told me that we had to have been having a flooding issue. So when we went into it, that's when well, I say we, it was me at this point. It was before the other guys got there. That's when I verified that I was showing per the readings that I was not flooding. So I wasn't showing that we were flooding via the temperature or saturation on the evap. But I had a negative discharge superheat, so I had to have had flooding. So obviously there's something weird going on with the low side readings. And what that told me at this point is I'm very convinced that I had already washed the oil out of the compressor. So I'm confident in that. Yes, YCIV. So I'm confident that the oil has been washed out. And it doesn't sound like we've got an oil seal on these screw bolts at this point. So I can understand that if we don't have the oil in the oil seal, that is causing if we don't have the oil or the oil seal, that is causing a higher amp than it should be, because we're not having the proper, we're having too much friction trying to turn the screws without proper oil. Now, getting into J, sounds that the evaporator may be oil logged. Close off butterfly to about 60% to get that oil moving. Close off. Okay, so I agree with, so part of what we did, I our evap load is running, it's a DX evaporator, and we have so once this circuit got pulled down, we were running about 48 to 50 entering, and the circuit that would run was maintaining the 42 out. So trying to turn this one on was maintaining 42 out. That was our current water load at the time. Seeing that I was having a severe flooding issue, I set a current limit of 30%, which kept the compressor ramped down. And then I went to the suction valve and I manually modulated the suction valve by hand in order to try to stop the heavy slugging that was washing out the compressor. I had limited success, but ultimately there was so much stacked in the evaporator, I had realized that the refrigerant migrated into the evap. So I know that, yeah, between oil and refrigerant, I've migrated, and it's stacked in that evaporator at this point. So I went ahead. Next step was I verified calibration on the drain and feed valve. Now the feed valve guaranteed has a problem. When I calibrated that, that valve was not moving properly. You could even hear it. The drain valve sounded perfect. It was absolutely perfect. Didn't have any issues. It moved in and out just fine. So I hooked up recovery on the two-phase line coming into the evap, pulled that out and pulled all the standing liquid out of the evaporator and pumped it back into the liquid line. So that got all the heavy liquid out of the evap and moved it into the condenser, the high side. And then I took I still need to get the oil into the compressor, because at this point I'm very confident I'd lost my oil seal. So I put probably about 1.5 gallons of oil directly into the I'm sorry guys, directly into the filter port on the compressor in order to get oil directly into the compressor so that we can get an oil seal on the bolts again and try to get refrigerant moving. That had very limited success. So and this is where this turns weird. It's where this turns very weird. And why I'm worried that it may be too late for this compressor. I'm still having the overcurrent, and when it turned on, prior to me adding the oil, I was only doing about 60 psi on the discharge. After adding the oil, it started to quiet down for a second like it should have, and my discharge pressure came up to about 125 psi, which is the best I had gotten it to all day. But I still tripped on the overcurrent, and that's the thing that's getting me, is the overcurrent still got me. So what I would have expected, once I got that oil in there and actually got some compression happening and things started to move, that things would have started to recover well enough that that I should have been able to start maintaining online, or I should have at minimum seen a much lower compression, I'm sorry, a much lower amp draw once I got the oil in there. And just my problem is it's not what I had. It's not the conditions that I saw. My amp draw was still elevated even though I had put that oil in. Now, after that, it shuts down and it shuts back down on the overload, and then the and I see the comments going. I see some really good ones I want to come back to. I'm trying to get my thoughts out while I've got it here, and then I want to talk through the comments a little more here in a second. So just bear with me. But keep the comments coming, because I see some things in there that may actually be pretty useful. Anyway, the part that's tripping me. Okay, we get to the final conclusion. As it stands right now, after I did that oil, my discharge pressure at startup goes from, so I'm at 40 psi between suction and discharge and oil pressure. All three are equalized at 40. After the compressor starts, I get about 45 to 60 seconds of runtime. It doesn't sound good at all during that time frame. My suction barely fluctuates, if moves at all, and my discharge and oil pressure both drop. So I start off at 40, then I drop to 30, then to 20, and eventually I get down to 0 psi. And by the time I hit 0 psi on the discharge and oil transducers, the by the time I hit that, I have by the time I've hit that, I've got no. By the time I hit 0 psi, my current limit trips out, and my suction side did not do anything more than maybe slightly fluctuate. I'm still sitting at that 40 psi mark, and I did put an actual analog on the suction at where the transducer reads, and the exact same service valve there at the back side of the compressor, and I still, like, that's exactly what my analog was reflecting at the time. So somehow my suction pressure didn't really change much at all, but my discharge pressure drops, and I don't understand how I've lost discharge pressure even though my suction is maintaining. Doesn't make any sense at all to me. Okay, I'm gonna read through some of the comments now. Let's back up a little bit here. What is your pressure differential on the barrel water side? It's I don't remember the exact pressure differential. It's a few psi. We know that the flow has been calibrated on these. So I'm not concerned with a flow issue, and I have other circuits that are running just fine at where the flow is. Foaming oil means refrigerant is boiling inside oil. Yes, completely agree. Well logged evap, Chris Dunaway. Yes, I do agree. I think our evap was definitely oil logged / refrigerant logged, but I did hook the recovery up and I pulled that out of there. It is a DX barrel. I've had but I'm not sensor problems. Yeah, so far I haven't seen a dramatic thing that indicates to me it's just a sensor. Motor cooling circuit possibly. So this compressor is not, it doesn't have cooling. It's suction cooled, It doesn't have a dedicated motor cooling. CIV. Sell them a new one. Yeah, that's a whole different conversation. See, I don't know Yorks, but this sounds like a evap load. Evap load we talked about. We got plenty of evap load, but within range. Like we don't have a high pull down at the time of me trying to turn this on. Like I said, GPM is good. DX on the barrel. Discharge superheat is key. Yeah, like the discharge superheat was definitely running low. It was not looking good. But again, I've only got, so it's not that abnormal for the discharge superheat to look funny at startup. So that bothers me a lot less than it's not good. I don't want to see the discharge superheat I had, but it always does. It doesn't look at startup. You can't really look that close at it. So you can close off the discharge valve on the compressor to get it to raise up that pressure to get it to migrate. And close off the discharge valve on the compressor to get it to raise up the pressure. So you're restricting, but the pressure reading I'm getting, so this machine is reading pressure after the oil separator. As it comes out of the top of the separator, it Y's out, and on one of the Y's, because we have a dual circuit or dual coil banks, off of one of those Y's is the transducer. So it's after the oil separator, and the discharge isolation valve is between the compressor and separator. So I would ask that if you can expand on that one a little bit more, please. Drain valve sticking open or overfeeding. I questioned the drain valve. Something may have happened to it initially, but I don't think the drain valve is causing my problem right now. That's still giving me the overcurrent issue and the oil, getting the oil back. And why? And specifically, real specifically, why the heck am I seeing my discharge pressure fall out after the circuit turns on? And when the compressor shuts off, it has that usual backflow swoosh through it that you would normally hear with a screw. So all of those things are happening. Yeah, that's why the flash tank was reading 5 to 6%, but the actual level, so at one point I was able to get a condensate line on the flash tank, and I was running about 40 to 50% of actual like liquid level, which the way those flash tanks work, the liquid level sensor isn't like that legitimately accurate. But anyway, I'm not overfilled on the flash tank, I guess is what I'm saying. Just had a YCIV, 100-degree motor temps. The valve was sticking. Danfoss valves are prone to it. I have the Sporlan. Was it a Sporlan? Pretty sure I've got the Sporlan valves. I don't have the Danfoss ones. In this particular machine. 100-degree. Need to recover from the bottom of the evap to the separator for 45 minutes, then let it sit for 4 or 5 hours, then try firing it up. And I like the idea. So my struggle that still doesn't explain my discharge, but even if we can't explain that, fine. Like I can get over that. I need to get, which I guess I could put oil into the directly into the compressor. And so you're saying let it go into, put everything into the separator, let the oil settle out, and then let the refrigerant migrate out of the separator, and ideally would leave the oil behind. Okay, I have to think about that one some more. If anybody has any thoughts on the discharge thing, granted, I know I'm kind of behind on the comments. What's happening? What happened to the load over time? Losing the seal alone would pump all the oil out of compressor, but with the evaporated load, it should come back. I agree, and we definitely have load on the evaporator. And the load is we've been able to maintain the load around 50 degrees consistently. I'm having the same problems. The oil left the compressor. Check the CT relays. Home amount. No, I didn't, to be honest. Jason. That's EV. Are they actually overamping, or is something wrong with the logic board? No, we are overamping in this case. That is an issue. We have not megged the compressor at this point. I will say that, BK, that we haven't done that. It would be worth trying, but I guess one reason why we haven't dove into the electrical side is because the symptoms we're seeing live on site, which is really hard for me to translate in this format, but everything looks mechanical in nature. So between the refrigerant, the oil, all of those things, it looks very mechanically, or it looks like a mechanical problem. So we've not paid a ton of attention to the electrical side, which maybe that's part of our downfall. Maybe that's something we should look more into that, and maybe because but still, okay, so we got some kind of electrical issue somewhere. Maybe that IGBT, even though it hadn't been in there that long, maybe it's created an issue somehow, and it's not outputting properly, which leads to the overcurrent, leads to the growling. So maybe we're putting too much faith in an IGBT, which is a known failed component. Circuit 2, the down circuit, has a brand new IGBT that's basically had almost no runtime on it, because that all happened about the same time. When that compressor went down, we had literally just done that IGBT. So, okay, so maybe we could switch IGBTs from 2 to 1, see if that makes a difference, and actually look closer into that. Okay, so I can get behind that. That doesn't explain the rest of it, but I do feel like if I can get the circuit to just stabilize, that's the thing. I can only get it to run 60 seconds at a time, and that's not enough for these machines. So I need to figure that part out. CT. That sound like possibly more than one thing. I think it very well could be one. I think what we're dealing with is the symptoms of something that happened. So I think we're trying to figure out how to get this thing to run, and what we're struggling with is the symptom of whatever happened that got it to this state. So the first thing we got to do is get it to stay online again, and then after we get that far, then we can figure out why this happened to begin with. VSD logic board can cause either compressor high amp draw or low hertz on startup. This is true. The logic board, if it was a logic board issue, it's not guaranteed, but I would expect to see issues on circuit 3, which can run without question. But It doesn't mean that it's because there's two different termination points between compressor 1 and 3. So there could be something there. That goes back to the electrical side. Again, and maybe that's part of our downfall, is we didn't spend enough time thinking about it electrically. We got really honed in, we got blinders on the mechanical aspect of it, and we didn't put enough thought into the electrical controls aspect. I will admit that right now. Logic board has adjustable blue boxes. Changed 8 EEVs in 2 seasons. Yeah, those EEVs are horrible about going out. And I've had several brand new out of the box last a month, and then they crap out again. Lots, yes. Are they moving? Just change one. I just got here, but is your phasing correct? Almost sound like compressor's running backwards, lol. So funny thing there on the reverse rotation, we looked into that, and out of pure experiment, like what else are we gonna do kind of thing, I did actually reverse rotation. I reverse phase just to see what would happen. And I surprisingly, I had no difference in my readings. So I swapped L1 and 2 because when I saw the discharge start pulling down and doing what it was, that's where my brain was on the same track. So swapped the legs, didn't change a thing. Amp draw was still spot on, exactly the same. I still pulled down the discharge the same. I swapped the legs back, and it didn't matter which way I had the phasing, the compressor reacted identically. And again, figure that, I just, how does that make sense? We should have seen a dramatic change there, and we definitely didn't. Let's see. And keep in mind, I've called every local expert I can think of and know, and I've talked to everybody. None of us have ever seen, heard of, or anything on any of these kind of conditions. Like, none of us have been through this before, or even heard of it. So we're all interested to see what this turns into. Let's see, what are the hertz on the VSD logic board, as well as input and output? So it's commanding for 50 hertz at that point, at the command. The command is 50 hertz, and it shows that the output is actually 50 hertz. We have not actually read the output to verify 50 hertz or not. Is the service valve fully open on the transducer? Yes, both transducers are fully open. I can guarantee that. Also, there is a place here in Dallas that rebuilds those boards as well. Logic issue is possible. Jay, please email me who those people are that rebuilds those boards. I have a handful of customers who would really like to look at that option. Just please send me an email for those folks. I'm really glad you mentioned that. Flash tank level sensor. That was throughout all this testing was reading between 5 and 6% flash tank level. Looks like the screws are giving up. I mean, that's what we're questioning, is there an issue with the screw bolts? If there is, like, if this is a bad compressor, I'm completely okay with that. But I'm not at a place where I can tell the customer, yeah, without a doubt, bad compressor. And because ultimately, think about it. Say, okay, I don't think they will, but say they did decide to do the compressor. We slap one in, we get the same symptoms. You're talking these compressors are 20 grand. These are $20,000 compressors. These are not just a chunk of compressor out and see what happens. So I'm okay with that resolution, but it better dang well be the right resolution. Really sounds like an algorithm issue in the logic. And part of why I'm pushing back Uh, part of why I'm pushing back so much on the logic is I had a current limit set on the logic to 30% current, so it would not it wasn't allowing the compressor to stage beyond those 50 hertz. And maybe that's part of my mistake. That's something I did think about at 1.2 was if you know, maybe I'm contributing to the problem by not letting the compressor ramp up. That is something we can test tomorrow, and we've talked about possibly trying to do, is not limit it at startup. Just for are you gauging up on the unit or relaying on transducers? Michael Gonzalez, I'm doing both. I do have some gauges on the system, but I am heavily looking at the transducers as it stands currently. I do trust those transducers. Is it a king valve? I had a busted king valve that had me. I don't think we got a valve issue. I was wondering if the compressor is losing compression for some reason for another. Well, I mean, I do feel like we're losing compression because we're losing our oil seal. You know, I mean, if you don't know, it just screws. And I talked about this in the recent chiller training we did last week. You know, screws require an oil seal on the bolts in order to create compression. Without it, they just don't work. Also, someone mentioned on here to check the phasing. Yeah, so we talked about that. Swap them, rule of thumb. Why did circuit 2 go down? Circuit 2 has a locked rotor, which, like you're saying, you know, if there's something with the logic board and that's causing some irregularities, absolutely. I think there's a lot of room for you to be completely right. So those logics are a pain in the ever-living butt to troubleshoot. But yeah, compressor 2 or circuit 2 has a locked rotor, which that's the one I did a short on. I couldn't even tell you when now, weeks ago. I have a short on that one where I was doing some in-depth testing, hoping it wasn't the compressor, but that was the final outcome, is that it turned out to be a lock rotor. Logic board sounds like running backwards. Yeah, I talked about that earlier. We tried swapping the phases, didn't make a difference. I would throw a phase meter on it as well when you tried to run it next, just to be positive rotation is correct. That would be worth doing. I will say that unless if the phasing swapped, it had to have done it in the IGBT itself. So yeah, which at that point would just lead back to an IGBT issue. So swapping circuit 2 and circuit 1 IGBTs may be well worth our time tomorrow, for sure. Have you verified water flow apart from the flow meter? Not this particular time, but we have in the past. We've confirmed and done a balancing on this chiller plant, so I didn't put really any time into the balancing this particular call. Is there a check valve on the discharge line? There is not a check valve on the discharge, and there is an isolation valve. It's not a check valve, it's just a ball valve. And the transducer is after the isolation valve. But I see where your mind is at with that on the check valve thing. If that was there, we'd probably be condemning it, honestly. 60 seconds, right? Yeah, 60 seconds is just nothing for these things. I mean, that's part of the problem. Is how do I get this thing to run for more than 60 seconds? See, through VSD data on the control panel, you can see what the overload current is set at. So 232 is my trip overload on the VSD. And so I'm actually, yeah, I'm legitimately hitting that each time. If the overload is moving, you need some help. Yeah. Restriction in the separator. I don't know how. So this oil separator is just a basic separator. It's a inside input with a dual Y output going to the two different coil banks, and it's just a big cylinder. It's not like a carrier or a handbell where we've got the mesh assembly or anything in there. So it's just a big cavity that, at least that I'm aware of. If I'm wrong on that, you're welcome to let me know. Oh yeah, Jason. Yeah, he got that. I forget the series. That Fluke Megger. I think is nice. Yeah, Chris Stevens over at HVACR Videos sent him that. That's pretty cool. In here, if you had no change in the afterward after swapping the legs, do you broken shafts? So we talked about, okay, do we have a shaft issue? Is it broken? Is something wrong at the bolts themselves? And where I have pushback with that line of thought is, you have a bearing on the inner and outer side of the bolt, and then from the bearings, you bolt in the middle. You go through the inner bearing. You go through the inner bearing. You have a shaft sticking out that goes into your rotor assembly. Then you have a rotor attached to that shaft, which spins inside of the stator. So if we had something where that shaft sheared from the rotor, then it wouldn't have anything really supporting it necessarily, and it would just, I don't see how it could turn at all. It would just tear the inside of the stator up. And we're actually like the rotor, the bolts are actually able to turn and create some kind of refrigerant movement. So yeah, I don't think that's it. Screws may be warped. Yeah, it's possible. Yeah, I really am thinking that that we may have had a severe flood to begin with, whether it be the suction sensors or the drain valve or something somewhere caused a flood or something that started this whole sequence. Your screws do not handle liquid input whatsoever at all. See, it's a 40K. Let's see, if your oil logs, and you know you are, adding oil will only make oil carryover worse. You need to move as much oil as you can and let the refrigerant boil off. I do agree. Adding oil is not my preferred method at all. Part of my goal there is to add just enough to create enough of the seal that I need in order to get it to start pumping and moving properly, and it would be something I would want to remove after the fact. And so once all this is said and done, I would want to go in and pull whatever excess oil is now in the system using the sight glasses on the separator. That would be my next steps once we get all this figured out. I'm definitely not going to leave it in there. This isn't good, guys. I'm getting to the end of the comments. If you see, give it enough time to have. It's true. Yeah, we can't. Yeah, that's the challenging thing to this. You know, this is the kind of stuff that separates chiller tech or people who are capable of servicing chillers is you've got a data center, you've got millions of dollars of equipment, you've got customers who they're trying to not have an insurance claim, and yeah, time pressure. If you're doing have enough oil in oil form and not foam, your problems will persist. Okay, that's a good point. So yeah, if we've basically boiled all the oil into the refrigerant and it's not settled anywhere, we're only going to continue making it worse, especially by adding oil. Let's see, economizer, EEV. So the YCIV has a solenoid on the economizer that triggers. The YVAA series, which is the series after the YCIV, uses an EEV on the economizer. So if you mean the actual economizer valve and you're not meaning the feed valve, which the feed valve is having issues. Let's see. Is the full of sounds to me like an intermittent obstruction before your discharge transducer. If you could lose pressure and pump against the head, which could lead to overcurrent if the compressor hasn't failed. Yeah. If you run screws backwards, doesn't that cause... Yes, screws do not... theoretically, screws don't run backwards. Most of the time they seize up when they do. So the fact that... Yeah, I'll be honest. The fact that I was able to swap those legs and swap the phases like that, and I got no changing results, I will tell you that screws my world pretty good on my understanding of screw. Yeah, I don't like that. I don't like that at all. Did you pull oil filter and look for any signs of metal? No, we haven't pulled the oil filter. I mean, yeah, at that point we're getting into condemning compressor bearing issue. Don't Chris Dunaway, when you say don't, what do you mean by don't? Give me a little more here, please. You've had some great input, by the way. I appreciate you, buddy. Back end bearing on the second screw grenaded. Okay, so on the female screw. Okay. So let's think through that. So that's going to cause, it's just going to rumble inside of there. That's going to cause an alignment issue on the screw bolts. It's not going to compress. It's not really going to do much of anything. It would cause an excessive load. Would that compressor, so this is a VSD too, so you've got pretty minimal starting torque with a VSD compared to like a regular starter, where it just hits. You've got a lot more starting torque on something like that, just because it's giving it a lot more juice. So if we blew out the secondary bearing, it's a legit theory, but at that point I would question, would that VSD still have enough torque that it could even start the thing without overcurrenting? That would be, yeah. Yeah, I will definitely be updating. I'm actually shooting a video on this whole thing, so we'll see where that goes. I don't know, this may turn into one of those that hits the archive and never sees the light of day. There's not very many of those. I have had a couple, I'm not gonna lie. Open and inspect the compressor. So we could do an open and inspect. The thing with the open and inspect is the customers at a really, it's hard to explain the bigger picture here without spending the next hour and a half. Ultimately, it is not worth it for the customer to do the open and inspect and then us try to get the system back together or the compressor back together. It's just, given the bigger picture, which I can't explain, it doesn't, it's not, they're beyond that, I guess is what I'm saying. Good input though. If that was a better option than it currently is, we would probably definitely be doing that. So the high level problem is we're having an overcurrent, and we're only getting about 60 seconds of runtime. There's an overcurrent during that runtime. It starts off, we're at about 150, 60 amps, 85% current, or 85% RLA. After about 60 seconds, that exceeds the current limit safety, and we're exceeding 262 amps. And we have a growling in the compressor, a very audible one. We have lost oil in the separator, and I'm very confident we've lost oil, the oil seal in the compressor. And when the compressor goes to start up, the discharge pressure falls. So at startup, we've got 40 psi across the board between suction, oil, and discharge transducers. Suction transducer maintains about the same, but the discharge and oil transducers both fall together from 40 psi. By the end of the 60 seconds when we're tripping, we're at 0 psi. I do have an analog gauge on this suction transducer showing, now the analog gauge is fluttering, which the challenge there is it fluttering because of pressure, or is it fluttering because that compressor is just shaking violently due to the oil bearing issues. So the the analog has a bad flutter to it while it's trying to run. Sounds like you need 2 new screw and logic boards. Do you have? So we are working on rentals, just so you know. We're in progress on the rentals. It's just right now our rental market in my area is beyond severe. They're not available is the biggest issue. They're genuinely not. So, but we're working on it. We got some friends in good places that might be able to help us out. Is there a muffler? There is a muffler. I'm leaning towards the restriction and would check discharge pressure at the compressor versus, ooh, okay, all right. Damn, I didn't even think about the muffler. Okay, that's a real thought. All right. So yeah, coming directly out of the compressor, you've got the muffler. It's the very first thing you hit at the 90. We have a high pressure switch there in the discharge cavity, so we could isolate the compressor, pump it down. Well, actually, could we? Well, yeah, we could get a gauge there at that discharge pre-muffler and see what what we show on the actual discharge housing. So what is our discharge housing pressure versus our transducer pressure, which is after the oil separator. That's a really good point. We didn't think of that one. See, I thought the board corrects phasing before starting compressor. Well, I don't know how the board would be able to know the phasing after the inverter. It can correct phasing, so if your input phasing from the main lines is reversed, it can correct that, so VFDs will do that. But your output phasing, it does not correct. It doesn't do that on its own. Any solenoids for Freon migration? Well, we've got the drain valve, which, you know, we're not 100% on, but it appeared to be working. And then you have the economizer valve as well. Plugged separator. I don't know how that separator would plug. I guess I need to pull a submittal on those separators and see how their internals are, and if they have the mesh chambers like you see on some separators. Not all of them have that though. Some of them are just tubes that everything flies into. Did the discharge isolation ball valve vibrate closed? You know. We didn't check that, and you want to talk? We didn't check that. Now that you mention it, and I'm not gonna. Yeah, we should check that. Yeah, we'll check that. Train had a problem. Train had that problem. Now we put metal locks on all discharge ball valves. Interesting. Huh. That's a good point. Yep, gotta look into that. Does the VFD check phasing and automatically reverse it? So that may be the reason for the change. Well, so the VFD, it would correct input phasing, but unless I'm wrong, it's not going to correct output phasing. It's only going to correct for input phasing, and I switched it at the output phasing. I didn't say that earlier, but just to clarify that, that's where I switched it over at. We don't have discharge check. Thermal cam, yeah, we could. I don't have one. I don't think we have one on site. That's not a bad idea. Compressor's bad, no restrictions, no miswiring. And I just heard what you said. I'd agree with compressor is kicking the bucket. You're not tripping on pressure, but over amping. Yeah, I know. That's my thing though, is if I can save this thing, it is worth the time spent to save it without going to extreme measures. And so that's what we're trying to do. Really, that's what it boils down to, is we're trying to save this thing if possible. If it's not, so be it. Fine, we'll walk away from it. We'll figure out plan B. I'm okay with that answer. Yes, it is a York compressor. You aren't reading across separator. No. Well, let's see. Yes. We have discharge, which is after the separator. We have the oil. Well, no, we're not reading literally across it. So we don't have a reading discharge line pre-separator, discharge line post-separator. So we don't have that. And I don't think we have that capacity. And I don't think there's a port to read from. Jason, Jason, what we'll do, we're going to get there in the morning, and we've got some other ideas too on some things we're going to try. We've had some really good things we need to look into while we're there in the morning. So specifically the IGBTs, look into the electrical side. So anyway, we'll follow up in the morning on whether or not we're going to grab that thermal and just kind of go from there. We may, I mean, ultimately it may be worth the time spent checking it. I've seen, that's funny, I guess I haven't actually seen a ball valve close on me, at least not that I can remember. Thank you everybody. Yeah, just keeping it real. Yeah. My edits are rarely that heavily edited. I mostly just try to make it easy to watch and to the point without stupid extra hoopla on most of my stuff. But what you see is what you get. Okay, yeah, I really appreciate the input, guys. I think we've got some legitimate next steps. Something we talked about trying ourselves before we left the site was we're gonna run a bypass hose from the discharge line to the suction line and see if somehow bypassing, if that changes anything. Really, we're just trying to create any kind of change than what we currently have. So we're gonna try that as well. We need to look into the electrical issues a little deeper and really take a closer inspection of that. And then we also need to, we talked about putting a magnet on the economizer valve and forcing that open to see if that just, again, change anything. That's all I'm really wanting to do. I want to see something different than what I've seen, because everything I've seen isn't good. Even if the something different is something worse just gives us more of a direction. Right now we're kind of at this tipping point. Is it actually the compressor? And it's an easy thing to blame, it really is, but is it actually the compressor, or is something else insignificant that we're just having trouble pinpointing in our way? Yeah, we'll check. Yeah, we're gonna, I promise you, Chris, that ball valve is going to be the very first thing I walk up to and put hands on in the morning. And if it's, yeah, if that turns out to be just a ball valve, yeah, I don't, yeah, I might just pack my tools up. I don't know. That'd be the dumbest thing in the world to cause all this. But it's legit. That could be a real problem. If the discharge valve vibrated closed, wouldn't the compressor trip on high head if it was running? You would think if the high pressure switch on the discharge housing was running, you would think. Yeah, $100. Yeah. Yeah, right. Send me an email. Okay. Well, we got some legit direction. We really do. We got some very legitimate direction. We got some great input. I appreciate it, guys. I need to get home to the family. I'm still about an hour from the house where I'm at now. So, yeah, time to go spend time with them. I really appreciate everybody's time. I will let you know how it goes. And actually, while we're at it, we'll get everybody in the vlog. So everybody say hi to yourselves. If this makes it to a video, or when it does, heck, maybe a month or so from now before it does, then yeah, we'll make this part of this will be just some random thing. For everybody who watches the video who had no part of this, they're gonna have no idea what this means. But yeah, we'll figure it out. Having fun. We'll see you guys. Thank y'all very much. I'll catch you later. Thankfully, all this chat will be saved, so while we're there tomorrow, we'll be able to do a quick scroll through and see everybody's stuff. Appreciate y'all.